In this video, we will cover the path control. First of all, why we need path control. Nowadays, guys, networks are designed in a backup format for high availability. However, the use of multiple routing protocols and redundant connectivity options can sometimes lead to inefficient ways to route packages to their targets. The administrative distance, metric, and network lifetime of each routing protocol are different. So, for example, redistribution changes the administrative distance and metric value, so redistribution might lead to inefficient routes. In summary, to avoid performance problems that may arise with different situations and to optimize routes, we need path control. So, policy-based routing is a technique used in networking to make routing decisions based on policies defined by network administrators rather than just the destination IP address. So, PBR allows you to specify routing decisions based on various criteria such as source IP address, destination IP address, application type, or even packet size. So policies are defined using access list or other criteria. These policies dictate how packets should be routed based on characteristics beyond standard destination-based routing. So PBR can use a range of criteria to influence routing decisions, including the source IP, destination IP, protocol type, packet size, even application type. So policies are applied to inbound traffic on router's interface, and when packets arrive, they are evaluated against the defined policies to determine their routing path. PBR allows for more granular control over routing behavior. This can be useful for implementing traffic engineering, load balancing, or prioritizing specific types of traffic. So if I just want to configure a policy-based routing on Router 2, first of all, I need to go and define my ACL to match the criteria for the specific PBR. Okay, how I'm doing it? First, I am going ahead and typing IP access list extended and with a name, ACL use vector. So basically I'm defining an extended access list in here. This access list will match the traffic coming from this host, which is the PC in here, going through this host, which is the server in here, and using the port number 1001 with TCP. Okay, so basically any traffic coming from this host with TCP 1001 going to this server will be a match for this ACL. Then I'm going ahead and defining a route map. Okay, so the syntax is route map and the name of the route map permit 10, route map PBR permit 10. And I am going ahead and match the IP address that I used in my ACL above, okay, with the command of match IP address ACL use vector. Then I am setting a next hop, okay, set IP next hop, and I am typing the next hop IP address, which is 192.168.12.1, and that is this interface of router 1. Then what I am doing in router 1, I am going into the interface mode, which is a tunnel interface for this case, basically this interface, and I am applying my policy route by using IP policy route map and the name of the route map command. That is it. So in detail, what happens when this guy generates a traffic for this server over TCP port number 1001, the traffic will come here. From here it will reach the router 2. So router 2 basically has two paths. Okay, it can prefer this path, okay, to reach router 1, or it can prefer this path. But since we already created a PBR for this specific traffic, the router 2 will send this packet directly to this interface of router 1. This is how we are doing the path control with policy-based routing. We can do the path control with IPSLA also. Okay, that is a method used to monitor and manage network paths based on the performance metrics gathered by IPSLA operations. So IPSLA provides real-time measurements of network performance such as latency, jitter, and packet loss, which can be used to influence routing decisions and optimize path selection. So IPSLA can perform multiple tests such as ping, ICMP echo, TCP connect, HTTP, and more to measure the network performance, and it provides data on round trip time, jitter, packet loss, and response times. So routing protocols or path control mechanisms can use IPSLA metrics to dynamically adjust routing decisions. If an IPSLA operation detects poor performance or a failure on a primary path, it can trigger a switch to a backup path. Here is a pretty basic configuration for IPSLA, for example. I have my customer edge router and I am using two different ISPs to reach the internet from this customer network. So I want the traffic coming from customer local area network should go from this way by using ISP1 if my defined LSA is up. Otherwise, I want the traffic should be going through from this path over the ISP2 if the SLA goes down. Okay, so how I am doing the configuration? First of all, I am defining a track. Okay, for this case, track and the track ID, track 8, IPSLA 1, and the reachability. Then I'm going ahead and defining my IPSLA 1 statement in here. Okay, so IPSLA 1 is ICMP echo 10.0.12.2, source IP 10.0.12.1. Okay, so what happens in here really, for IPSLA, I am checking the reachability to 10.0.12.2. How I am doing it? I am sending ping packets from this interface of this router. Okay, just sending ping packets. And then I'm giving a schedule in here, which is not really a big deal. Then what I'm doing, I'm defining two default routes. Okay, the first one is IP route 00000000 10.0.12.2. This is the interface of ISP1 with a track 8. What is this? And the second one is IP route 0000000010.0.13.2. That is ISP2 interface with an administrative distance of 10. Okay, so in this scenario, guys, basically this one is the backup route. Okay, and this one is my active route. So how I'm defining it? I'm defining a default route, IP route, and a default route with a next hop of my ISP1 interface. And here I am tracking track 8. What is track 8? It is tracking the reachability for IPSLA1. So what IPSLA1 checking? It is sending ping to this IP address. So story short, if the ping that this router customer edge sending to this 10.0.12.2 is successful, the customer local area network will prefer ISP1 to reach the internet, okay? But somehow, if the ping fails, okay, that means the track will go down. That means this route won't be used anymore, okay? This won't be my active route, and my backup route will take over, and the traffic will start to be flowing through the ISP2 in this case. Alright guys, we are coming to the end of this session as well, and thank you so much for joining me.